Good evening, guys.
Good evening.
We'll get started with the next exercise of vectors. So in the first exercise, I'm hoping that you have no doubts. The second exercise, listen. Addition of vectors. Okay. So if AB bar is taken as a vector, if it simply means the displacement, see if I take a vector AB starting at point A towards point B. Now, let's say we are moving from point A to point B. Then from point B, if you are moving towards point C, then what is going to be the net displacement of us? So what do you mean by displacement? Displacement is the shortest path traveled by an object, right? So when we go from A to B and we go from B to C, okay, then the displacement of the particle will be from A to C. Okay, then what we can say is AB vector plus BC vector is the same as AC vector. See, if I take them as line segments, then I cannot write this. I cannot say AB plus BC is equal to AC. That's not true. But AB as a vector plus BC as a vector is the same as AC as a vector. And this law is called as the triangle of addition of vectors. So how to apply this triangle of addition is, if there is a point where you're starting and you know the point where the first vector is ending. So the ending point of the first vector, if it is a starting point of the second vector, then the resultant, that is the third vector, is equal to the starting point of the first vector and the ending point of the second vector. See, it's starting at A, it has gone to B. So the second vector is starting at B and it has gone to C. So AB vector plus BC vector, when I take it like this, will be equal to AC vector. Okay. So in general, if you have two vectors, A vector and B vector, then to add them, they are positioned so that the initial point of one coincides with the terminal point of the other. So that is what I meant here. Are you guys able to understand what I told here? I'll try to make it simple. I'll not explain everything from the textbook. I'll try to make certain. This is clear, right? Okay. Then, listen. So there is something called as Parallelogram Law of Vectors. So remember, Parallelogram Law of Vectors and Triangle of Vectors mean the same. The only difference is, when will you apply triangle of vectors is when the ending point of the first vector acts as the starting point of the second vector, you will go with the concept of triangle of addition. Whereas when there are two vectors and both the vectors are starting from the same point, which are called as co-initial vectors. So if you have co-initial vectors, then what I can say is, if there is A vector like this and B vector like this starting from point O, then I can always draw vector B, which is parallel to B vector of the same magnitude. Then the name of that vector will be B vector. Similarly, for A vector, I can draw a vector which is parallel to it, which I call it as A vector. Then what will happen is, observe, if I cover this point, if I cover this portion, right, then how is it looking now? Is it not looking like a triangle? Where the ending point of the first vector is the starting point of the second vector. When this is going to happen, tell me, OA vector plus AC vector will be equal to OC vector. What is OA vector? It will be A vector plus this will be B vector is equal to OC vector. So OC vector will be A vector plus B vector. Now observe. Where did the actual B vector come from? Actual B vector is a coinitial vector. Right? Actual A vector is also a coinitial vector. Then this A vector plus B vector actually represents the diagonal of this parallelogram. So are you able to understand? So when there are two coinitial vectors and you want to find the resultant means sum. When you want to find the resultant of these two vectors in terms of magnitude and direction, it is given by the diagonal that is passing through the common point of these two vectors, which is A vector plus B vector. Are you able to understand this point? So what I'm trying to say is, there are two important laws with respect to addition. What are the two laws? One is triangle law and the second is parallelogram law of vectors. So when you take these two into consideration, they both actually mean the same. Okay. The next important thing is properties of vector addition. If A vector and B vector are two vectors and you want to add them, then A vector plus B vector will generate the same result as that of B vector plus A vector, which is a property called as commutative property. This is called as the commutative property. Next. Okay. The property number 2 is, if you add A to B and add the result of that to C, then it is the same of adding A to the result of B plus C. So A vector plus B vector plus C vector is the same as A vector plus B vector plus C vector, which is called as the associative property of that particular addition. Right. Next is, if you add 0 vector to any vector A, then that will give you the same as, so it is using a commutative property. A vector plus 0 vector is the same as 0 vector plus A vector is the same as the vector itself. So the 0 is called as the additive identity for the vector addition. So additive identity generally means you have a number, and to that number you need to add a value so that you will get back the number which you wanted. So A to which if I add a 0, I'll get back A. So that 0 is generally called as the additive identity. In the case of vectors, that 0 vector is called as the additive identity of that vector. Okay. Next is multiplication of vector by a scalar. So the multiplication of vector by a scalar, don't get mistaken with multiplication of two vectors. Multiplication of vector by a scalar means you have a vector, scalar is a number. If you take a vector and multiply that vector with a number, then you will get another vector. Okay. Let A be a vector and lambda is a scalar. Scalar means a number. Then the product of the vector A bar by the scalar lambda is denoted as lambda times A bar. And this is what we call it as the multiplication of a vector A bar by the scalar lambda. Okay. But here you need to note a point that when you multiply a scalar with a vector, what is the output you are getting? You will get another vector only. So scalar multiplied with vector lambda times A bar is also a vector, right? Which is generally collinear to vector A bar. What does it mean by collinear? Collinear means they can be along the same straight line or they are parallel to each other. Then lambda times A vector has the direction same to that of A vector according to the value of lambda. So if the value of lambda is positive, then A vector and lambda times A vector will have the same direction. If lambda is negative, then A vector and lambda times A vector will be in the opposite direction. Suppose you want to find the magnitude of vector lambda A, then it becomes magnitude of lambda times magnitude of A bar, which is going to be lambda into A. Is that clear, guys?
Yes, sir.
Okay. Now, here we saw what is additive identity. Next is we will see what is additive inverse. So if there is a number x, then you want the inverse of it, you need to add minus x to it so that you get 0. So the additive inverse of a number is nothing but the negative of that number. Then you have something called as multiplicative inverse. So multiplicative inverse is what? So generally here you will not have multiplicative inverse because you can't divide two vectors. Yeah. So if if lambda into a bar represents a unit vector in the direction of a bar, we write a cap is equal to a vector divided by magnitude of a vector. So what they are trying to say is, if lambda into a bar is a unit vector, then the magnitude of lambda into a bar is 1. So we know that magnitude of lambda into a bar is magnitude of lambda into magnitude of a bar is equal to 1. So we know the fact that okay, I already made this. So they have unnecessarily wrote this. So I have already told you that a vector is equal to magnitude of a vector into a cap. So what is the formula for a cap then? It is magnitude of a vector, sorry, a vector divided by the magnitude of a vector. So which is going to be this value. Okay, is it clear, guys?
Yes, sir.
Okay. The next one is called as components of a vector, or generally it is called as rectangular components also. So components means if I take any vector in the space, see, for example, if I take this as a vector, okay, or if I take this as a vector plus b vector, for example, then what I can do is I can drop a perpendicular here, I can drop a perpendicular here. When I do that, if O is a starting point, you remember what is parallelogram law of vectors? So for parallelogram law of vectors, if you have two coinitial vectors, then you can write the resultant. Whereas in this case, what will happen is you have the resultant, then you can write those two coinitial vectors due to which this resultant is formed. So that is breaking the resultant into its subcomponents is what we call it as components of a vector. So a vector plus b vector is the main vector that is broken into two components because a vector plus b vector is comprised due to two vectors. What are they? A and b. Where I can say a is along x-axis and b is along y-axis, or the vice versa. We don't know in this case. But the process of breaking the main vector into two vectors is what we call it as components. Did you understand what it means?
So could you repeat?
So, you know what is resolution of vectors, right, in physics?
Yes, sir.
The same thing. Those resolved things are what are called as components. So, if it is a vector plus b vector, then what I can do is I can take one of the vectors to be like this, and I will take another vector to be like this. So, what I'm trying to say is this a vector plus b vector itself is formed due to two other coinitial vectors, where one of the vectors is a vector and the other vector is b vector. This a vector and b vector are individually called as components of the vector a plus b. So generally a vector I can call it as x component and b vector I'll call it as y component. Okay. See, generally you will not apply all these things in mathematics. They have just given it for the sake of theory because the problem solving technique for mathematics is slightly different. So I'll explain it at that point. Okay. Listen. Then there is something called as orthogonal unit vectors. So what are these orthogonal unit vectors? The vectors which are used to represent the direction along x, y, and z axis are called as orthogonal unit vectors. So orthogonal generally means perpendicular. Unit vectors, you know, any vector whose magnitude is 1 is what we call it as unit vector. So generally, I cap is a vector which is used to represent anything moving along x direction. Similarly, j cap is used to represent anything moving along y direction, and k cap is used for anything that is moving along z direction. So I cap, j cap, and k cap put together are called as orthogonal unit vectors. Okay. So what I'm trying to say is, listen, if I take a point P in this plane, okay, if I take O as the initial point, then if I join it like this, then what I can do is from this point, I'll drop a perpendicular, which I call it as X. And from this point, I will call this as Y. Then if I call OP as R, then I can say OP vector is comprised. So OP vector, according to parallelogram law of vectors, what will you say? It is X units in the direction of X axis, that is I cap, and Y units in the direction of J cap. Did you understand what I did? Then this OP vector can be called as R vector, where this X and Y are called as components of the vector R. Is it clear, guys?
Yes, sir. Clear.
Okay. Now listen. So, what is the magnitude of R vector? That is root of x square plus y square. Magnitude of R vector means the distance from O to point P. This is x, okay, x. If this is y, this will become y. Then this forms a right angle triangle. Then x square plus y square will be equal to R square. Okay. So if I extend the same thing to a plane, to a space, if there is a point x comma y comma z, then what will happen? R vector will be equal to x I cap plus y j cap plus z k cap. Then what is the magnitude of R vector? Root of x square plus y square plus z square. Okay. Listen. If A vector and B vector are any two vectors given in the component A1 I cap plus A2 j cap plus A3 k cap, where A1 is called as which component? A1 is a coefficient of I cap. So I cap corresponds to x axis. So A1 is called as what is it? It's called as x component. A2 is called as y component, and A3 is called as z component. Okay. So if the two vectors are given as A1 I cap plus A2 j cap plus A3 k cap, then the sum or resultant corresponding to the vectors A vector and B vector will be something like this. A vector plus B vector will be A1 plus B1 I cap plus A2 plus B2 j cap plus A3 plus B3 k cap. So the difference of the vector A vector and B vector is given as A vector minus B vector is equal to A1 minus B1 I cap plus A2 minus B2 j cap plus A3 minus B3 k cap. So the vectors A and B, when can you say them to be equal? A1 when the x components are equal, y components are equal, and z components are equal. Similarly, the multiplication of scalar by, so the multiplication of vector A bar by a scalar is going to give us lambda times A1 I cap plus lambda times A2 j cap plus lambda times A3 k cap. Okay. Clear, guys?
Yes, sir. Clear.
Just a minute. Okay. No. So I'll start the problems. Find the value of x, y, and z so that the vectors are equal. So what should you do? A vector is equal to B vector only if their x components are equal. So x should be equal to 2, y should be equal to 2, and z should be equal to 1. Do you understand how I found out?
Yes, sir.
Right. Let A vector be I plus 2j and B vector is 2i plus j, then magnitude of A is equal to magnitude of B. Are the vectors A and B equal? So magnitude of A vector is how much? Root of 1 square plus 2 square. Magnitude of B vector is root of 2 square plus 1 square. Both are root 5. Accepted. But are they both equal? Are they both equal?
No,
Yes,
sir.
They are not
The
equal
magnitude are
because
different.
So their
the coefficients
components.
are not. Yes, the coefficient, that is the components. More technically, they are called as components, are not the same. Similarly, sixth one. Find the unit vector in the direction of vector A bar. Just give me a second. Yeah. Find the unit vector in the direction of A vector. So, A vector is 2i cap plus 3j cap plus k cap. Okay. Then, what is the unit vector for it? A cap is equal to how much? A vector divided by magnitude of A vector. Just now I told you. Right. A cap is equal to A vector divided by magnitude of A vector. So 2i cap plus 3j cap plus k cap divided by, what is the magnitude of A vector, guys? Root of 2 square plus 3 square plus 1 square. So 2i cap plus 3j cap plus k cap, the whole divided by square root of how much? 4 plus 9, 13, 13 plus 1, 14, square root of 14. So the unit vector in the direction of this vector is 2 by root 14 I cap plus 3 by root 14 j cap plus 1 by root 14 k cap. So this is the vector. Example 7. Find the vector in the direction of vector this thing that has a magnitude of 7 units. So what is the difference between find the unit vector in the direction and find a vector in the direction? What is the difference? So what is the difference, guys? Hey, please respond. I'm not able to shout. So here we are talking about unit vector. Here you're talking only about vector. Means what you're supposed to do for these kind of problems is first find the unit vector. First find the unit vector. So what is A cap? I cap minus 2j cap divided by root 5. and multiply this with the magnitude of 7 units. So 7 times a cap will be equal to 7 by root 5 I cap minus 14 by root 5 j cap. Okay. Next is find the unit vector in the direction of sum of the vectors. So what is the meaning of this? Find the unit vector in the direction of sum of these two vectors. So sum of these two vectors, if I call it as C vector, then it will be how much? 4i cap.
4i cap plus 3j cap minus 2k cap.
Yes. So what will be the unit vector in this direction? So C cap is equal to how much? C vector divided by magnitude of C vector. That will be 4i cap plus 3j cap minus 2k cap divided by square root of 16 plus 9 plus 4. So 4i cap plus 3j cap minus 2k cap divided by square root of 29. So this is the unit vector which is in the direction of sum of those two vectors. Only thing is when you're writing them, write it as 4 by root 29, 3 by root 29 minus 2 by root 29. Okay. Next. Write the direction. Okay, direction ratios I'll tell you later. Next is vector joining 2 points. So if I want vector joining 2 points, so there are 2 points P x1 y1 z1 and P2 x2 y2 z2. If I want to write the vector P1 P2, okay, then I need the position vectors of those two vectors. So what do you mean by position vectors?
The
So
vector
position
starts from the origin.
origin. So what is OP1? It is x1 I cap. It is x1 I cap plus y1 j cap plus z1 k cap. And the OP2 vector is x2 I cap plus y2 j cap plus z2 k cap. Right. Now see, OP1 vector plus P1 P2 vector is the same as OP2 vector. What did they actually use? What did they use?
Triangle
A
law.
triangle of addition. So what is it we need to find? P1 P2 vector. Can I write it as OP2 vector minus OP1 vector? So OP2 vector is final vector minus OP1 vector is initial vector. So what is final vector? X2 I cap plus Y2 j cap plus Z2 k cap minus this will be X1 I cap plus Y1 j cap plus Z1 k cap. So what I'm trying to say is final position minus initial position vector will give you the vector itself. Okay. Example 10. Find the vector joining the points this from P to Q. So I need to find PQ vector. Then what is the answer for this? It is OQ. So final position vector minus initial position vector. It is OQ vector minus OP vector. So OQ vector evlo? Minus I cap minus 2j cap minus 4k cap minus what is OP vector? 2I cap plus 3j cap plus 0 times k cap. So are you able to understand this?
Yes, sir.
So it will be minus 3I cap plus j cap minus 4k cap. Yeah. Next is section formula. See, for section formula, what we are supposed to do is, if I have 2 points P and Q and I know their position vector. So position vector of point P is A vector, position vector of B is B vector. Sorry, Q is B vector. Then I have a point R which is dividing PQ in the ratio M is to N respectively. Then can I write OR vector is equal to, observe, M into Q vector or M into OQ vector plus N into OP vector divided by M plus N. So M into OQ vector is B vector plus N into OP vector is A vector, the whole divided by M plus N. So this is what is called as, this is the position vector of the point which is dividing the points P and Q in the ratio M is to N internally. Okay. Sometimes what will happen, there will be an external division taking place. When external division is taking place, then you write OR vector as M into OR vector minus N into, sorry, not OR, M into OQ vector minus N into OP vector divided by M minus N. So M into OQ vector is B vector minus N into A vector divided by M minus N. So this is going to give you the value of OR vector. Right. Suppose R is the midpoint, then M would have been equal to N, then OR vector will be A plus B divided by 2. So if you observe, all these formulae are similar to the section formula. So if you see, these formulas similar to what happened in coordinate geometry, right? Now see, consider 2 points P and Q with the position vector OP vector as this and OQ vector as this. Find the position vector of a point R which divides the line joining P and Q in the ratio 2:1 internally. Tell me. Then OR vector is equal to M into OQ vector final plus N into OP vector, that is initial, divided by M plus N. So M is how much? 2. 2 into A vector plus B vector plus N is 1 into OP vector, that is 3A vector minus 2B vector, the whole divided by 2 minus 1. So it becomes 2A vector plus 2B vector plus 3A vector minus 2B vector, 2 plus 1 is 3. So this becomes 5A vector divided by 3. So 5A vector divided by 3 is going to be the position vector of R, which is dividing the points P and Q internally in that ratio. So externally, now what are you supposed to do? Replace replace with plus with minus sign. You will get the required answer. That comes out to be 4 times B vector minus A vector. Right. Example 12. Show that the points A, B, C are the vertices of a right angle triangle. How will you show that they are the vertices of right angle triangle? So they have given ABC, right? What have they given actually? They have given you the position vectors. So OA vector is how much, guys? 2i cap minus j cap plus k cap. What is OB vector? I cap minus 3j cap minus 5k cap. OC vector is 3i cap minus 4j cap minus 4k cap. So what is AB vector? AB vector is OB vector minus OA vector. So for you to prove something is a right angle triangle, what are we supposed to do? To prove something is a right angle triangle, what are we supposed to do?
Sir, Pythagoras theorem.
Pythagoras.
Very good. So when I find AB vector is going to be OB vector minus OA vector. So minus I cap, 3 add. So minus 3 plus 1, minus 2j cap, minus 6k cap. Okay. What is BC vector? So BC vector is 2i cap minus j cap, plus k cap. AC vector evlo? AC vector is I cap minus 3j cap minus 5k cap. Right. Now find the magnitude of AB vector. Magnitude of AB vector is root of 1 square plus 4 plus 36. That will be root 41. Magnitude of BC vector is root of 2 square plus 1 plus 1 square plus 1 square. Root of 5 plus 1, root 6. So what is the magnitude of AC vector? That is root of 1 square plus 3 square plus 5 square. That will be root of 1 plus 9 plus 25. That will be root 39. Now what we can do is 39 and 6 seem to be small. Root 41 correct then. So I'm getting root 45.
Sir, it's root 35.
25.
Yes,
So
sir,
this is
root
root
35.
35. Yeah, root 35. So AC square plus BC square is equal to AB square. Accepted.
Yes, sir.
So that's the answer. Okay. Now what I will do, I'll explain you the outline of 10.2. I'll give you the hints. It is your job to solve it before tomorrow. Okay. So compute the magnitude means what are you supposed to do? Root of, make it fast, root of 1 square
1 plus 1 plus 1, sir. Root 3.
Yes. Minute. Device got stuck. Okay. So write two different vectors which have the same magnitude. So A vector I can write as I cap plus 2j cap, and B vector I can write as 2i cap plus j cap. They both are different vectors, but they have the same magnitude. Write two different vectors having same direction. So if I have to write two vectors, A vector will be I cap plus 2j cap, B vector will be 2i cap plus 4j cap. Now how did I say that they both have the same direction? So when two vectors have the same direction, what are they called as technically? They're called
Direction
as
cosine, sir.
no. Wait, I didn't use the word direction cosines at all. If you have heard it somewhere, forget it. I'll explain it clearly in the next chapter. Forget about direction cosines and ratios. If two vectors have the same direction, then they are said to be collinear or parallel vectors, correct? So what is the condition for collinear or parallel vectors? A vector will be equal to lambda times B vector. If this is I plus 2j, observe this is 2i plus 4j, means B vector is 2 times A vector. Seriya? Fourth, find the value of x and y so that the vector 2i cap plus 3j cap and xi plus yj cap are equal. So what is the value of x and y? 2, find the scalar and the vector components of the vectors with the initial point 2, 1 and terminal point 5, 1. Tell me, so if I take this point as P, this point as Q, what is PQ vector? OQ vector minus OP vector. That will be
Yes, sir.
minus 7i cap plus 6j cap. So find the scalar and the vector components.
Scalar is -7 and 6. Vector is -7 I cap plus 6.
That's it. Sixth one. Find the sum of the vectors. You just add them. 1 minus 2 plus 1, 0. 0 I cap plus minus 2 plus 4. 2, 2 minus 6 is minus 4j cap. 1 plus 5, 6, 6 minus 1 is 7, 7 is minus 1. So minus k cap. Okay. Seventh one, you can do it. Find the unit vector. A cap is equal to A vector divided by magnitude of A vector. Find the unit vector in the direction of PQ vector, where P and Q are these points. So how will you do it? First, find PQ vector by using OQ vector minus OP vector. Then what am I supposed to do? PQ cap is what you need to find. PQ cap will be PQ vector divided by magnitude of PQ vector. Ninth one. For given vectors A and B, find the unit vector in the direction of A plus B. So what are we supposed to tell me the steps? Tell me the steps, sir. This I already solved my example problem. A vector is given, B vector is given. Find the unit vector. Unit vector in which direction?
A plus
The
plus.
direction
We can add
A
A
plus
vector and B vector.
So first add A and B. I'll call it as C vector. Then they're asking C cap. C cap another. C vector divided by magnitude of C vector. Yeah, you can do that. 10th one another. Find a vector in the direction of vector given like this, whose magnitude is 8 units. So what are you supposed to do? First find the
Unit vector.
correct. First find the unit vector and multiply that unit vector with
8.
very good. 11th one, show that the vectors are collinear. By looking at them, you can say if this is A vector,
something which is proportional.
A vector, this is B vector. B vector, if I take that minus 2 outside, I can write it as 2i cap minus 3j cap plus 4k cap, correct?
Yes.
Can I write it like this? So this is what? Is this not A vector? So B vector is equal to minus 2 times A vector. So lambda times A vector. Hence it is collinear. Direction cosines not needed. So see, I'm not saying not needed means they're not deleted. I'll explain the same concept in the next chapter better. Okay. 14th one, that is also based on direction cosines only, so not needed as of now. 15th one, paranga. Find the position vector of point R which divides the line joining P and Q in the ratio 2:1 internally and 2:1 externally. So P, Q and R, M, N. So M into OQ vector plus N into OP vector divided by M plus N. Correct? Can you do this? This is P, this is Q. I've solved an example already. Find the position vector of the midpoint of these two. So what are we supposed to do? Add them and write So OR vector will be equal to 2 plus 4 by 2. So 3i cap plus 2j cap plus 2k cap. This will be the midpoint. 17th, you know how to do it. A, B, and C are given. They're asking you to prove that they are the vertices of a right angle triangle. Find AB vector, BC vector, and AC vector and apply Pythagoras theorem. You'll get the answer. 18th. So which of the following is not true according to this diagram? AB vector plus BC vector is equal to how much? So what
AC
I
vector.
Yes, AB vector plus BC vector is equal to AC vector. Right. So AB vector plus BC vector minus AC vector is 0 vector. Accepted. So B
Yes.
is right. Minus AC vector is the same as CA vector.
Yes, sir.
So it becomes plus CA vector is equal to null vector. So A is also right. But AB vector plus BC vector minus AC vector is also right. So what is wrong? This is the one that is wrong. Okay. 19th. If A vector and B vector are two collinear vectors, if A vector and B vector are two collinear vectors, then which of the following are incorrect? B vector is equal to lambda times A vector, correct? It is correct. A vector is equal to plus or minus B vector. It is right because 1 times lambda or minus 1 times lambda, it is still a scalar value. The respective components A and B vector are not proportional. Both A vector and B vector have same direction, but different magnitudes. Correct? Actually, this is also wrong only. A vector and B vector have same direction, but different magnitudes. Actually, it is an ambiguous statement. They can have different magnitudes also. They can have equal magnitudes also, but it is not a compulsion that they should have a different magnitude. Is it clear? Then we are left out with two more exercises. That is, so till now we saw what is addition of vectors. Then we have product of vectors. There is no concept of division of vectors. So in product of vectors, next class I'll start with scalar or dot product. Once that is over, then we'll go to vector product. Okay, with that, this chapter will be over. So by Wednesday, I'll close it. And next Monday, I'll start three-dimensional geometry. Okay, next week, 3-dimension, and the week next to it, probability. That's with that, we are done. Any other doubt from today's class, guys?
No, sir.
No doubts.
Okay, then we can wind up.
Thank you, sir.
Thank you, sir.